RCHUB International Foundation for Research and Education, and ISO certified.
Good day, everyone. Okay, okay then. Let me share my PPT. Okay. So is my PPT visible?
Yes, visible.
So, foundation for data analysis. What if I say the data analysis, which completely deals with statistics, is very simple to understand? I know it may sound crazy, but the thing is that it's actually true. The fact is that when it comes to the data analysis, which is mostly is now completely oriented with statistics, uh, deals with only four important parts. So that is what I'm going to illustrate it right now. So before getting into the topic, I just wanted to give a glimpse of what this data analysis is all about and what for this data analysis is being done and how to make interpretation using AI. So this is what is the core topic here. So that's what I'm going to talk about, the foundation of data analysis and AI tools. So when it comes to study, when it comes to making a research, we all deal. This is what we do. Generally, we make data collection and we organize it or scrutinize in such a way that it is really ready for analysis. Once analysis is been done, we make interpretation, we make presentation. So this is what is a proper protocol, and there is nothing big difference. But the thing is that the major problem arises is that when it comes to statistics. Many people think the statistics is a very hard part. It completely deals with the numbers. It is really complex to understand. But actually, the data analysis, which is actually 90% which is statistics, is really easy. So the most important concepts, what you have to understand is these things, what I'm going to illustrate it right now. What I'm going to say it right now, take it to a heart, because this particular session, this 1 hour may give you a huge glimpse of ideas of what this entire data analysis and statistics is all about. And once you have understood this, you will know what kind of data analysis or what kind of statistical technique need to be applied for your data set. And with using those statistical technique, what you have to do, what kind of analysis has to be made using various applications and how to make an interpretation using AI too. So this is what I'm going to teach you right now. So the first and fundamental concept what here you have to understand is the population and sample. So I hope you all know when it comes to research, there are two important things what you have to understand. One is a population and another is a sample. So what is a population? A population is nothing but the entire respondents or the data set that is being available in the environment. So that is what is population. Whereas sample is a representative of the population. Say for example, if you wanted to know the satisfaction level of the e-commerce platform, say Amazon, you could go take survey from all 2.1 billion people around the India. That's practically impossible. But instead, you can go for collecting a sample, go for collecting data from at least 385 samples who represent the entire population, who generally uses the Amazon platform. So what is the satisfaction level of these 385 samples, which we have selected as a representative of the entire population? That is what is sample. A sample is a representative of the entire population. Generally, when we do research, we don't go for census or we don't go for full data analysis. That is practically impossible because practically speaking, collecting the entire census or collecting the entire data set in real time is impossible. So we always go with the samples which are the representative of the entire population. So once we have collected this required amount of sample which are reliable, now note the word which are reliable, because the thing is that for the sake of collecting the sample is completely different. If you wanted to collect your right reliable data, you have to approach the right respondents, that is right sample. That's very important. That's what I'm telling, right reliable sample. Okay. So once the sample has been collected, once from the sample, the data has been collected. So once a sample has been selected, and from them, once the data has been collected, the next important thing is that scrutinizing the data set. There will be some unengaged respondents. There will be some missing data. There will be some data set that is completely flawed, which we can easily observe. So I'm not here to talk about how to scrutinize those data set, but let us get into the topic. Let me hit the bullseye. So the most important thing is that once the data has been scrutinized, so we will think about the next step is we will think about the statistics. So what kind of statistical technique do I need to employ with my own data set? Say, I tell you what, when it comes to statistics, there are only two, it could be categorized into two important parts. One is a descriptive statistics and second is inferential statistics. Or let me simply put, a descriptive statistics is nothing but statistics or a data analysis which describes a data set, What is the most repeated value? For example, if you're going to check the mileage of the Royal Enfield bike, what is the most repeated value? Say, for example, most of the bike is giving the mileage of 30 kilometer per liter. So that is the most repeated value. On an average, what is the mileage given by the Royal Enfield bike? So mean. So these kind of things that describes a data set is nothing but is the descriptive statistics. There are various then comes inferential statistics. So next is inferential statistics. I told you, right? If there are more than two variables involved in the study, at that point of time, we go for inferential statistics. So when we speak about inferential statistics, the entire statistics is it only deals with these four things when there is two or more variables. We generally do statistics to find whether there is significant association between two variables or not. Whether is there significant relationship between the two variables or not. Whether is there significant influence between the two variables or not. Whether is there significant difference between the variables considered for the study or not. So it is for these purpose we do the entire statistics. So when I talk about statistics, we do statistics only for these 5 reasons. What are those 5 reasons? First is to describe the data set, which is called as a descriptive statistics. And second, we will try to identify whether both the variables, what we are considering for the study, has significant association with one another. Or we will try to identify is the variables we have considered for the study has significant relationship with one another, or is one variable is influencing the another variable, or is there any significant difference in the variables. It is for these 5 important purposes we do the entire statistics. Statistics is as simple as this. So now you may have a question. Okay, so the entire statistics only deals with these 5. It is for these 5 reasons we are doing the statistics. So it is for what kind of statistical techniques do I need to employ for each and everything? So that will be your next important question, right? So it is for this. Say, for example, you have to understand the data set. Generally, when it comes to data, when it comes to statistics, research will say there are different types of data. Say, for example, scale, ordinal, ratio, so many types. But in reality, there are only 2 different types of data. One is the categorical data, and second is the metric data. These are the 2 important data types with respect to statistics. These are the 2 important data types with respect to statistics. Statistics does not know the other different types of data types. So what is a categorical data? So when I say a categorical data, it means a group. Say, for example, male, female, it's a group, right? Smoker, not smoker. It's once again a group, right? A person who prefers tea, who prefers coffee. Once again, group, right? A person who is in rural area, urban area, or semi-urban area. So rural, urban, and semi-urban. So these are all the groups, right? So when the questionnaire has a following options that completely represents a group, then it is called as the categorical data. That is called as the categorical data. Excuse me. So, and then comes the metric data. So when it comes to metric data, it could be of anything. It could be of anything that deals with numbers, or it could be of anything that deals with a Likert scale question. Say, for example, some of you could be in science background, but yet I will tell you, science background, obviously you will be dealing with numbers. Say, for example, what is the BP of the patient, what is the height of the patient, what is the weight of the patient, what is the hemoglobin level. So that deals with numbers. But in case of social science studies, that deals with survey, sometimes you cannot measure the satisfaction. So at that point of time, they use as a Likert scale based question. So what is a Likert scale based question? Say, for example, how far you are satisfied with the shop? Say, for example, strongly disagree, neither agree nor agree, agree and strongly agree. So you see, there is a gradual increase, in the scale. So when the sample size is significant, and if you have used these kind of scales, this is called as Likert scale questions. So generally, when the questioner has the following options like a Likert scale based question, or if something that deals with numbers, at that point of time, it is called as a metric data. So when it comes to statistics, we are doing statistics only for this 5 purpose. Whether to describe the data set, which is called, for which we use descriptive statistics, and to identify whether there is significant association between the variables or not, or is there any significant relationship between the variables considered for the study or not, or is there any significant influence of one variable on the another variable or not, or is there any significant difference between the variables considered or not. And it is for 5 reasons we are doing statistics. And next important thing, the concept, what you have to understand is that when it comes to statistics, forget about your books. When it comes to statistics, there are only 2 different types of data. One is the categorical data that forms a group, and second is a metric data that deals with numbers or anything that deals with a Likert scale based question. So these are the 2 different types of data. So now you have a question. So now you may have a question. So I understood there are only 2 different types of data, and I understood it is for these 5 reasons we are doing the entire statistics. So now, how do I need to identify what kind of test do I need to employ? Because most often the researchers get confused that significant association test and significant relationship test both are one and the same. Actually, they are not. Logically speaking, they are completely different, and at the foundational level, they are very, very different. I tell you why. Say, for example, if both the data are categorical in nature, take these as a notes, because you can't see these kind of notes anywhere, because the thing is that I have clubbed both the statistics and data analysis together, so that these kind of notes you may not find it anywhere. So please take it. First and foremost is, if both the data are categorical nature, at that point of time we will use significant association test. If one data is categorical in nature and another variable is metric in nature, at that point of time we will use significant difference test. In case both the data are metric, at that point of time we will use significant relationship test or impact test. So I hope you got it. The thing is that when it comes to categorical data and metric data, these are the only 3 combinations out there. Either both the variable could be categorical in nature, or either both the variable could be metric in nature, or one variable could be categorical and another variable would be metric. So these are the only 3 combinations. And based on the 3 combination only, we are doing the 4 important inferential statistics. So now let me tell you what kind of statistical technique need to be employed based on the test. Say, for example, if both the data are categorical in nature, I told you, right? If both the data are categorical in nature, at that point of time, we will be using significant association test. So at that point of time, we will be using significant association test. When it comes to statistics, in order to do the significant association test, there are only two tests available. One is the chi-square test, and second is the correspondence analysis, or chi or chi-square test, whatever might be. So both the data are categorical nature. At that point of time, we will be doing the significant association test. This is done by two statistical techniques known as the chi-square test and the correspondence analysis. Say, for example, let me give you an example. Say, for example, you are going to a cancer institute and you have framed two questions, just two questions, two questions. The first question is, are you a smoker or a non-smoker? Are you a cancer patient or a non-cancer patient? So these are the two questions. Both are categorical data, right? So both are categorical data. Smoking, non-smoker, smoker, non-smoker, cancer, non-cancer patient. So you have identified that smoking, most of the smokers are cancer patients. So what you could say, there is some association between smoking and cancer. We could say, right? Here we cannot say there is significant difference between smoking and cancer. That is completely illogical. I hope you understand. That is completely illogical. But you may have a question. Why can't we say there is significant relationship between smoking and cancer? Actually, we cannot say that. I tell you why. So here you first get into the thought process. Here we could say there is significant association between smoking and cancer. There is association between smoking and cancer because most of the smokers are cancer patients. So this is one thing. Now I tell you why we cannot say there is significant relationship between smoking and the cancer. When it comes to relationship, it could be both positive and negative, right? It could be both positive and negative. And it is for this reason we are doing correlation analysis. If both the data are metric only, at that point of time, we will be doing significant relationship test using the statistical technique called as correlation. Using the statistical technique called as correlation. So, say for example, we all know that as the India population increases, the GDP decreases. They have negative relationship. They have negative relationship. So the relation, it happens. One is impacting both have relationship. We all know. Similarly, the GDP and industry index also have a relationship because as the GDP industry index increases, the GDP also increases. So which means we could clearly say that the relationship could be either positive or negative. So this is what is called as, this is what is a major difference. In association, we cannot say there is a positive association or negative association. We cannot say that, yeah, smoking is positively associated with cancer. We could simply say that, yes, smoking and cancer has some association. We cannot say whether it is positive or negative. Whereas in relationship, we could clearly say there is positive relationship or negative relationship. We could say that as the India population increases, the GDP decreases. They have negative relationship. As the industry index increases, the GDP also increases. They have positive relationship. So this is what is the major difference when it comes to relationship and association. In association, we cannot say whether it is positive or negative, but here in significant relationship test, we can clearly say that there is positive or negative relationship. That's a major difference between the significant association test and significant relationship test. Okay, so now we have found out that there is significant relationship between the both the variables, but you don't know exactly what is causing what. How far one is impacting the another variable, which is simply called as a forecasting. So here we could clearly understand that. Excuse me. Is my PPT visible? Is my voice audible? Do you have any?
Yes, yes, sir. You're audible.
Okay, okay, okay then. So just hold on a minute, ma. Okay. Sorry, ma'am. Okay then. So where I was stopped? Yeah. Uh, yeah. I have not explained regression analysis, right? Yeah, that's the thing. Okay. So when we talk about regression analysis, it's all about. Is my PPT visible?
Yes, sir.
Yes,
PPT is
yes.
visible, sir.
Okay, ma'am. Okay. So great.
Thank you,
So
sir.
that's the thing. So the first and foremost is that we have found that both the variables have significant relationship. If we have both, we have found that both the variables have significant relationship, but we don't know how far one variable is influencing the another variable. At that point of time, we will be using regression analysis. I tell you what, this regression analysis is what is called as the forecasting analysis. It is through this the entire forecasting has been done. There are various types of regression analysis, and in fact, it's a complete what do I say? The thing is that it goes on and on. Actually, what we are seeing or what we are dealing with respect to data analysis is very limited as a researcher. We do only a linear research, or actually there are so many types of research and even many econometrics models that completely comes under this regression analysis. Say we have exponential, cubic, sine, power, logistic regressions, and there are various types of arch family tests, autoregressive models, VAR models, VECM, vector error correction models. All the fundamental here is nothing but the regression analysis. So this is a vast topic, but I don't want to get into too much into the numbers or the statistics. I want you to understand the foundation of the statistics and foundation of data analysis. So this is what it is. So if you have found that both the variables are related to one another, and if you wanted to find how far one variable is impacting the another variable, at that point of time you will do regression analysis, which is nothing but significant influence test. Say for example, you have understood that as a population increases, GDP decreases, but how far? Say for example, if our population have reached 3 billion, what will be our Indian GDP? As of now, if this is the population, what will be our GDP? So this is what through regression analysis you can derive the regression estimates or equation through which you may able to forecast. So that's the beauty of significant influence test. So the final thing is a significance difference test. So I told you, right? If one variable is categorical in nature and another variable is metric in nature, at that point of time, we will be using significant difference test, or we call it as the T test. So I tell you what, say for example, consider like this, say for a, excuse me. Uh, Sorry, I'm having some technical problem here. My system is getting updated. That's why. So, okay. Let me move on to the point. Where have I left? Yeah, significance difference test. So, when it comes to significance difference test, there are various forms of significance. Let me give you an example. Say, for example, if one is a categorical data, another is a metric data. Say, for example, you are running a showroom, yeah, vehicle showroom, yeah, vehicle, a two-wheeler vehicle, and you're dealing with only three different types of scooters. Say, for example, Jupiter, Pleasure, and Scooty Pep. So these are all the categorical data, right? So different types of scooters, that is groups, Scooty Pep, Pleasure, and Jupiter. Both three or different bikes. And you're going to measure the mileage, which is completely numbered, metric data. So mileage of Scooty Pep is around 42, and Pleasure is 38, and Jupiter is 36. Here, you could say only there is significant difference in mileage, right? You cannot say there is significant association with mileage. It is completely illogical. You cannot say there is significant relationship with the mileage. That is also completely illogical. And you could only say there is significant difference in mileage. So that's what is the fundamental thing. So you have to say both the data are categorical in nature. At that point of time, you can say what is significant association between the variable or not. Because here you cannot say the positive or negative. If both the data are metric in nature, at that point of time, you have to do significant relationship test using correlation analysis. And at that point of time, you can say that there is positive relationship or negative relationship. In association, you cannot say whether there is positive or negative because both the data are categorical in nature. And similarly, if one data is categorical in nature and another data is metric in nature, logically, you will be telling only there is significant difference in the variable or not only. And when it comes to t-test, there are different types of t-test. And the most important thing what you have to understand, there is something called as non-parametric test and parametric test. I don't want to get deep into that because I want you to clearly understand what this entire statistics and data analysis is all about. And I tell you what, using the AI tools, any AI tools, I'm not talking about the Perplexity or Chat GPT. I'm telling that using any AI, you may clearly able to write an interpretation. And in fact, even if you don't understand the table, still you can write the interpretation. So that's the beauty, what you have right now in this era. So, okay, coming to the different types of statistical tests. Actually, there are different t-tests. We call it as one sample t-test, independent sample t-test, ANOVA and parity sample t-test. And I tell you what, there are different criteria for all these tests. The first and foremost, say for example, one sample t-test. When I say one sample t-test, it means you need to have a standard value. You need to have a standard value. Say, for example, you're dealing with one particular scooter known as Jupiter, the Jupiter from TVS brand, right? Okay, TVS Jupiter. And the company have claimed the mileage that the TVS Jupiter will be giving a mileage of nearly 36 kilometers per liter. So what you are doing is that you are measuring the mileage of 10 vehicles that have came to your showroom one by one. The first one is have given a mileage of 32 kilometer per liter. The second one have given a mileage of 38 kilometer per liter. The third one is 34. Fourth one is 35, and similarly it goes on. And you have found out that on an average, the TVS Jupiter is giving a mileage of only 34. Whereas actually the company have claimed that the TVS Jupiter will be giving a mileage of 36. There is a significant difference, right? Difference between the actual value and the standard value. So once there is a standard value, and when you're going to compare it against the actual value, at that point of time, you will be using the one sample t-test. So this is an important criteria, understand, so that when I do analysis, you may clearly able to observe how it is been done, what the table value is all about, and how to write an interpretation using AI. So pay attention to each and everything what I say. Generally, no statistician will be telling you all these things. So, yeah, yeah. So this is what is one sample t-test. And second is the independent sample t-test. As the name suggests, independent sample t-test, which means there will be only two categorical data. If there is only two categorical data, then at that point of time, you will be using independent sample t-test. I told you, right? Jupiter, Pleasure, and what is Scooty Pep. Yeah, three vehicles I said. Instead of three vehicles, you're going to compare only two vehicles. Say, for example, TVS Jupiter and Scooty Pep. There is only two categorical data, right? If there is only two categorical data and you're going to check whether there is significant difference in mileage, at that point of time, you'll be using independent sample t-test. So that is, it is for that independent sample t-test. In case if there is two plus categorical options, say the three vehicles, at that point of time, you will be using ANOVA. At that point of time, you will be using ANOVA. And paired sample t-test has a different set of criteria. I tell you when it will be used. The paired sample t-test will be generally used in certain cases where the same set of sample has to be tested at two different time intervals. At that point of time only, we will be using the paired sample t-test. Here, the same example. Say, for example, you are running the showroom, the vehicle showroom. You wanted to check whether there is significant difference in the mileage before and after service. So before service, the mileage of the Jupiter was 32, and after the service, the TVS Jupiter mileage was 36. So there is significant difference in the mileage. So the same sample, same vehicle, the TVS Jupiter, before the service and after the service. So same set of sample, but two different time intervals. If that is the criteria, we will be using paired sample t-test. Generally, we use most often in the sports and even sciences. Say, for example, if we wanted to see the recovery of the patient within two different methods. Say, for example, the first you are given a drug and you wanted to see how far his BP is getting normalized. So before, what is the BP? After giving the drug, what is the BP? So, and then you have tested the second drug. The same patient, what is the BP before and what is the BP after? So, which is giving the more appropriate, good result. So, that's the thing. So generally for science and the sports activities, these paired sample t-test are highly used. But in case your sample size is very low, which is very less than 30 or less than 35 or 30, at that point of time, you'll be using a non-parametric test, which is called as a Mann-Whitney test or Wilson rank test or Crooks-Wallis test, which is the compensatory for independent sample t-test, paired sample t-test, and ANOVA test. So this is what is the entire statistics is all about. This is what is the entire statistics. If you have understood what I tell you for this half an hour, you may able to employ a right statistical tool for your own data set. So the thing is that when it comes to data analysis, let me summarize everything what I have said right now. Because once you have understood this, getting into the real part of data analysis is very simple. So we are doing the entire data analysis using 90% of the data analysis using this statistical technique. And we are doing, when it comes to statistics, the statistic generally deals with 5 important parts. Either we do statistics for describing the data set, which is called as descriptive statistics, or to identify both the variables have significant association with one another, or is there a significant relationship between both the variables, or is there significant influence of one variable on another variable, or is there any significant difference between the variable. So it is for these purpose we do the entire statistics. And when it comes to statistics, there are only two different types of data. One is the categorical data and next one is the metric data. So what is a categorical data? A categorical data is any data that deals with groups. And metric data is a data that deals with numbers or any Likert scale based quotient. So this is what it is. So if both the data are categorical in nature, at that point of time, we will do significant association test. That is, we will try to identify whether both the categorical data are associated with one another using a statistical technique called as chi-square test or the correspondence analysis. Or else, if both the data are metric in nature, at that point of time, we will try to identify whether there is significant relationship between both the variables or not. If there is a relationship, whether is it a positive relationship or a negative relationship. It is for this purpose we will be doing correlation analysis, all types of correlation analysis. And in case if there is a significant relationship between both the variables or n number of variables when what we have considered for the study, at that point of time, we will try to identify the dependent variable and independent variable and we will try to perform a regression analysis through which we may able to identify how far a one variable is influencing the another variable. So then comes the significance difference test. So what is the criteria to do a significance difference test? If one data is categorical in nature and another data is metric in nature, at that point of time, you'll be doing significant difference test using various forms of t-test. And various forms of t-test, in a sense, it could be one sample t-test or independent sample t-test or ANOVA or paired sample t-test. So whatever might be, it has its own rules, a predefined protocol, and criteria at a point, criteria of when and how they need to be used. So, for example, when you have a standard value, at that point of time, you have to be using the one sample t-test. And in case if there are only two categories in your categorical data, in your questionnaire, at that point of time, you will be using the independent sample t-test. Yes, if you have more than two plus categorical options in your questionnaire, at that point of time, we'll be using ANOVA. And the important criteria for the paired sample t-test is that you're going to measure a particular value before and after an interval. At that point of time, you will be using the paired sample t-test. That is, a same sample is studied before and after a particular period of time. So that at that point of time, you will be using the paired sample t-test. So these all are parametric tests. I will tell you what this parametric test is all about and non-parametric test. Parametric test generally deals with mean value, that is the average value. And the thing is that the non-parametric test generally deals with the middle value. Whatever we have given as an option, the middle value will be considered as the average value. Whereas generally when the sample size is less and we have given a Likert scale based question, the statistics will not deal with the average value. They deal with the median value. That is the middle value. So as simple as this. So now let me start moving on with doing an analysis. Okay. So as of now, let me do a simple descriptive statistics. Yeah, I think that will do good. Okay. So let me stop sharing. Okay. So just hold on a minute, ma. Is my Word document visible? No, right? My Word document is not visible, right?
No.
No, sir.
So just hold on a minute, ma. Is it visible right now? Is it visible right now?
Yes.
Okay, ma. So actually, I have told you that descriptive statistics. So when it comes to descriptive statistics, it generally deals with only following aspects. It generally deals with only following aspects. Descriptive statistics. It generally deals with only following aspects. That is mean, median, mode, standard deviation, variance, skewness, and kurtosis. Okay. Generally, the descriptive statistics deals with only the following aspects. So I tell, okay. So mean is nothing but the average value. Mean is nothing but the average value. remember everything what I say right now, because when we start doing the analysis using some software, let me try to use a very simplistic software like Excel and SPSS so that everybody could easily able to understand. So I don't want to get into a complicated programming or a coding related software, so which may really make you clumsy. So don't worry. I'll be using very simplistic software for making data analysis, and I'll be using all types of AI. So, or else a simple AI. I tell you what, when the AI as of now are very intelligent enough to interpret all statistical tables. So, we will deal with any one or two AI tools. Okay. So, median is nothing but the middle value, and mode is the most repeated value. Standard deviation is how far the deviation is from the mean score. Deviation from the mean value, that is the square root. The square root of standard deviation is the variance. Many cases in generally the projectile path and all variance will be highly used, and even in regression model the variance will be highly used, but other parts it's not highly used. Okay, standard deviation. And then skewness is measure of flatness, or we could say skew, not, yeah, skewed, it's skewed actually, skewed. So for example, if I give you the, I have given you the, and I am the teacher and I have given you the question paper. And the question paper, I have made it in a very, very tough way. So what happens is that many samples, many of my students will be getting marks between 30 to 50. And only very least students will be getting the marks between 60 to 80. You see, most of the points will be crowded between the 30 to 80. Most of the students' marks will be crowded between the 30 to 80. That is what is skewness, whether it's left skewed or right skewed. Where is the mean value exactly relates? It is on the left side or the right side. So, for example, if I given you the question paper in a very easy way, very simple. So, what happens is that many people will be getting the marks between 60 to 90 or sometimes 60 to 95, and very least people will be getting less than 60. So, this here the skewness will be on the right side. So this is what it is. How most of the people will be concentrated on the right side, whether the curve, the distribution curve is on the left side or the right side, where it is exactly distributed, where the most of the respondents' values are situated. So it is to measure that the skewness is used. And kurtosis is the measure of peakness. Measure of peakness. Say, for example, in mostly in economics, say, for example, yes, particular news may shoot the price of the stocks. In order to measure those things, the kurtosis is highly used. This is what is the statistics. This is what is a descriptive entire statistics, what I talk about. So descriptive statistics deals only with all these are the important parameters, and inferential statistics is what I have already explained. So I hope you are clear with the entire the statistical the data analysis part. Now, what has to be done with the data? I hope you are clear with this. So once you're clear with the techniques, what has to be employed for the data set you have, then we can go for the data analysis. Okay, so is everything clear as of now? So tomorrow, I think actually we have many topics to get covered. So tomorrow I'll be rushing up. So stay with me. I took so much time in right now because this is the foundation where many people doesn't understand. And I personally believe that if you have understood this particular concepts well, then the other part of the data analysis becomes very simple. I tell you what, if you understood this particular session, the tomorrow session, when I go in a very, even in a very fast pace, you may be able to catch it up. So tomorrow we'll be doing different data analysis using a simple software, and I will also explain to you how to write an interpretation using AI tool. So is everything clear as of now, Ma? Is everything clear? Do anyone have any doubts in today's session? Is everything clear?
Yes, sir.
Do anyone have any doubts in today's session?
Sir, I have
Sir,
a
no.
question.
Yeah, please,
Sir, I
ma.
have a question.
Yeah,
Sir,
please.
please explain once more significant association test and
Significant.
significant relationship test.
Okay, ma. Say, for example, may I know your
Thank
name, ma?
Dr. Manjushree Mishra.
Okay. Say, for example, Manju and myself both are
Yes, sir.
doing a race, going for
Okay.
a race. The thing is
Okay,
that
sir.
the speed is measured in terms of kilometer per hour, right?
Okay.
Which is a metric data. So, which is a
Okay.
Manju, Dr. Manju is running at the speed of nearly 8 kilometer per hour, whereas myself is running only at 6 kilometer per hour. Do we have relationship?
Right. No, sir.
No, actually we have man. We both are doing same activity. We are
Do the
both
same
are
activity.
running.
Okay, okay.
Yeah, we
Yeah,
both
yes, I
are
understand.
running. So when
Okay.
Manju covers 8 kilometer, I will be covering only 6 kilometer. When Manju
Okay.
covers 16 kilometer, I will be covering only 12 kilometer.
Right.
So we
Yes.
both have positive relationship because we both are
Okay.
running in the same direction.
Same,
Dr.
same
Manju,
direction.
yeah, Dr. Manju and Dr.
Okay.
myself both are running in the same direction. So
Okay, sir.
we are having the positive relationship. But in case
Okay.
Manju is running in forward direction, whereas myself running in backward direction at
Okay.
6 kilometer per hour, whereas Manju is running in forward direction 8 kilometer per hour. Do we have
Okay.
relationship? Do we have
Yes,
relationship?
we
Yes, exactly. We
we
do
do
have
the same
relationship.
activity.
Yeah,
Yes,
we
sir.
are doing same activity, but here we
Yes.
have negative relationship. When
Negative
Manju
relationship.
covers
Okay.
8 kilometer forward, I cover 6 kilometer backward. You got me?
Okay.
We have
Yes, sir.
negative relationship.
Negative relationship.
So when
Okay.
both the data are metric in nature, here Manju speed is measured
Okay.
in kilometer per hour and myself, my speed is measured in kilometer per hour. If both the data are
Hmm.
metric in nature, at that point of
Yes.
time, we'll be measuring whether there is significant relationship between the variable. It could be positive or it could be
Or could be
negative.
negative. Thank you,
But
sir.
yeah, in case of association, both the data has
Yes,
to
sir.
be categorical in nature. I told you, right?
Okay.
Smoker and non-smoker, cancer and non-cancer
Yes.
patient, both are categorical data, right? Say, for
Okay. Yes, sir.
example, uh, say what Manju prefer, whether it's tea or coffee.
Tea.
Tea.
Yes.
Whereas myself, I prefer coffee. So we could say that
Okay.
most of the females are preferring tea. Most of the males are preferring coffee. There is
Hmm.
association between the preference, the beverage preference with
Okay.
respect to gender. We could say, right?
Yes, sir.
We cannot say there is significant relationship between the beverage preference. We cannot say, right? That is
Okay.
illogical,
Yes,
right?
sir.
Yeah,
Yes.
so this is the fundamental difference. When both are categorical in nature, categorical data, at that point of time, you will go for significant association
Significant
test.
association.
If both the data are
Right.
metric in nature, at that point of time, you'll be going for significant relationship test. You got me, ma?
Okay. Yes, sir.
Okay,
Thank you,
ma.
sir.
Very good. Okay, ma.
Thank you.
Anyone, any other doubts? Anyone else? So is today's, have you clearly understood what this entire statistics is all about? Have you understood the statistics is simple? It's not
Yes, sir.
complicated.
Yes, sir.
It's,
This is simple.
yes, ma'am. Actually, it's not as complicated as people say or think. It's as simple as this. Okay. So I hope I
Yes.
have made you understand that statistics and data analysis are very, very simple. So from tomorrow onwards, we'll be getting into the data analysis. I'll be using a simple tools like Excel and SPSS software so that without coding, because if I get into the coding like Python or R programming or MATLAB, you may get confused because there are people from various backgrounds. I don't want to complicate them. Okay. So even from arts and science, there are there. So I don't want to complicate them. I will be using simple software and I will teach you how to make an interpretation using AI. Okay, so I hope
Oh,
this is more than enough for today. So thank you all.
thank you so much,
Thank you,
sir.
sir.
Thank you, ma.
Good day,
Thank you,
sir.
Mavisi. Take care. Bye.
Good night, sir.
Good night.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.